Man, chemistry is so hard. It's like the hardest subject in the world. Wait, are you having a hard time with chemistry too? And the part with alcohols and ethers? Yeah, me too, man. I just can't seem to wrap my head around these kinds of things. If only there was someone who's willing to teach me how to... Wait, who are you?
I'm Mr. Chemistry!
But who are you? What are you doing in my house?
Never mind that, we're gonna learn chemistry!
Ah! Oh look, it's paint. But today we're going to be learning about alcohols and ethers. So, we'll be learning how to name them and we'll be learning about their special properties as chemical substances. So go ahead and grab a bowl of cereal and we're gonna dive straight into the world of chemistry. Woo!
We have an example of an organic molecule. This is an alcohol, more commonly known as isopropyl alcohol. We'll learn how to name it the IUPAC way later on. Like any other organic molecule, we must first determine the functional group. The functional group in alcohols is the hydroxy group, which is composed of an oxygen atom and a hydrogen atom. This hydroxy group is what sets aside the alcohols from other organic molecules. After you've determined the functional group, it's time to actually name this thing. The IUPAC system follows the parent, locator, suffix way of naming organic molecules. We'll fill out each part as we go. First, let's go with the parent. Parent means the parent chain or the longest continuous carbon chain which is connected to the functional group. In this case, we have 1, 2, and 3. Keeping in mind that there's a carbon atom right there in the middle. And we have different names depending on the number of carbon chains. We have here a table. If there's 1 carbon present, it's methane. 2, ethane. 3, propane. 4, butane. 5, pentane. 6, hexane. 7, heptane. 8, octane. 9, nonane. 10, decane. And more.
Man, that's a lot of names you gotta memorize just for the naming system, don't you think?
There's even ones for up to 100!
Man, do I love chemistry?
So the parent depends on the number of carbons present in the parent chain. Since we have 1, 2, and 3 carbons, our parent shall be propane. Now the suffix depends on the functional group or the type of molecule we're talking about. Since we're dealing with alcohols, our suffix shall be ol. Now, in IUPAC, we don't like vowels being next to each other. So we remove the E from propane. Propane-ol sounds wrong. So we replace it with propanol. We can end it here and call our molecule propanol. That's kind of correct. But for IUPAC, we need a little bit more. We need to specify on which carbon the functional group is attached to. Our hydroxy group is connected to the second carbon. So our locator will be 2. So, the specific IUPAC name of this molecule is propan-2-ol. That easy. After alcohols, let's talk about ethers. So let's name this ether molecule we have right here. So like alcohols, the first thing we have to do is determine the functional group. For alcohols, we have the OH or the hydroxy functional group. But for ethers, we simply have an oxygen atom. But this oxygen atom should be attached to 2 non-hydrogen atoms. So here we have the functional group for this ether molecule. So let's name this bad boy. Okay, so for alcohols, we follow the template parent, locator, suffix. But for ethers, it's gonna be a bit different. It's gonna be prefix, prefix, ether. Kind of like esters. Except of a suffix at the end, we just add the word ether at the end. So let's fill up both of the prefixes later on. So our 2 prefixes will be the 2 groups attached to our oxygen atom, our H3Cs. Let's focus on one group for a while. We will name the groups like we name parent chains. So let's go to our parent chart for a bit. We have 1 for methane. Yeah. So since we only have 1 carbon atom, we will use methane. But since it's not a parent chain, we will not use methane. Instead, we will use methyl, since it lacks a hydrogen atom. And since the other group is just the same, again, we will type methyl. Now, methyl is kind of correct, but it sounds weird. It sounds redundant. So the UPAC system offers a way to solve this problem. Let's go to our Latin prefixes chart. We have 1 for mono, 2 for di, 3 for tri, 4 for tetra, 5 for penta, 6 for hexa, 7 for hepta, 8 for octa, 9 for nona, and 10 for deca. And since we only have 2 methyl groups, we will use the prefix di. So instead of saying methyl, rather what we should be saying is dimethyl. Now it sounds more correct. And instead of adding a suffix at the end, we just simply add the word ether. So this molecule is simply dimethyl ether. It's that simple.
Wow, Mr. Chemistry, thanks for the help. That's exactly what I needed. Now I know how to name alcohols and ethers. Now I won't be flunking the test tomorrow. Yeah! Ah! Oh, wait.
Isa pa. Wag mo na.
Wait. Ah! Wait, baka i-shake mo na. Ah! Oh, wait, dapat i-shake.
Tapos titingin ka sa taas.
Okay, ready? Ah! Oh, look, it's paint.
Ay,
Here you go. Ah! Oh, look, it's paint. Ah!
Ikaw lang.
Ah! Oh, look, it's paint.
Wait, isa pa. Doon muna. Sa